If you've ever looked at a long transmission line problem, saw hyperbolic cosine, and felt your soul instantly leave your body, don't panic. Most students fail this topic because they try to memorize formulas instead of mastering the process. In this video, we are going to conquer ABCD parameters using just one ultimate master problem. By the end of this tutorial, you won't just understand it. You'll be ready to crush any power systems exam they throw at you. Let's make this easy. Step 1 requires calculating the characteristic impedance. To find this, we divide the total series impedance by the total shunt admittance, and then take the square root of that result. However, there is a critical limitation you will encounter during exams. The standard scientific calculators approved by professors and Professional Regulation Commission cannot calculate the square root of a complex number. This is where we use a secret weapon from advanced engineering math, de Moivre's theorem. According to de Moivre's theorem, taking the square root, which is just raising it to the power of 1/2, you just take the standard square root of the magnitude and have the angle. Step 2 requires finding the propagation constant multiplied by the total length of the line. This combined value is what we will plug directly into our hyperbolic functions later. To calculate this, we must multiply the total series impedance by the total shunt admittance, and then take the square root of the entire result. Apply de Moivre's theorem to handle the square root manually. Take the square root of your new magnitude value and divide the combined angle exactly by 2. Lastly, multiply the answer to the total length of the line. Step 3 requires calculating the hyperbolic cosine of the value we found in Step 2. This final result will give you both the A and D parameters for your transmission line. Because your exam-allowed calculator cannot process a complex number inside a hyperbolic function directly, we use a trigonometric identity to break it into a real part and an imaginary part. For this exact calculation to work, your calculator must be in radian mode. If you leave it in degree mode, the standard cosine and sine functions will give you completely wrong numbers. Once you calculate the real and imaginary parts, convert that rectangular answer into polar form. Your calculator will output the final phase angle in radians. Here is the final crucial exam step. Transmission line parameters are conventionally expressed with angles in degrees, not radians. To finish the step, take that final radian angle value and multiply it by 180 divided by pi. Step 4 requires finding the hyperbolic sine of our propagation value. This component is essential for calculating our remaining B and C parameters. Because of the calculator limitations, we must expand the expression using a trigonometric identity. Keep your calculator strictly in radian mode for this calculation. compute the real and imaginary components, convert the result into polar form. Just like in the previous step, the calculator outputs this phase angle in radians. To express it conventionally for engineering standards, multiply the angle by 180 divided by pi. Step 5 brings everything together to solve for the final ABCD parameters. To find parameter B, multiply the characteristic impedance we calculated in step 1 by the hyperbolic sine value from step 4. The resulting value represents the series transfer impedance of the line, measured in ohms. Parameter C. Divide hyperbolic sine value by the characteristic impedance. This gives you the shunt transfer admittance of the line, measured in Siemens. Thank you. Like and follow for more.